So we are going to do some extractions. So we have our urine, a quinine reference standard, and some water to serve as a blank. So first we have to make these alkaline, and then we have to extract with chloroform, and then we'll extract back into 0.05 molar or 1 normal sulfuric acid before we analyze the fluorescence. So the first thing we have to do is adjust the pH of our reference standard and our urine sample to be alkaline, which means it needs to be greater than pH 7. And so we're going to use we have some saturated potassium hydroxide that I left over here. So we'll check the pH initially for each of our samples. See where the pH lies. So this one is pretty neutral, it's right around 6. We'd like it to be alkaline, however. And our quinine reference sample is also down around 6. And our suspect urine, again, I'm dipping this into the solution that's left beaded in the lid so it's less likely to contaminate our solution. And that is also around 5 or 6. So we're going to add a small amount of potassium hydroxide. I'll let it dropwise using a Pasteur pipette. So I assume this is going to work relatively quickly. However, we'll see. So we'll add 1, 2, 1, 2, 1, 2. See how that does, and whether we need to add more. All right, we are highly alkaline in the water, as expected. Water has no buffering capacity. See how we're done in our... All right, our reference standard is also highly alkaline. And our urine sample also alkaline. So we're all well above 7. As you can tell from our little pH chart here, we're up around 8, and in some cases up around 11. All we needed was for it to be alkaline, so we're in good shape. So what I'm going to do is take 5 milliliters using the volumetric pipette. So I'm going to transfer 5 milliliters of each sample into a separatory funnel. And then I'm going to add chloroform to do our extraction. Oops. Try that again. All right, so we need 10 milliliters of chloroform. Now, chloroform is denser than water, so it's going to end up being our bottom layer. Actually going to do an extraction. All right, so we want these to settle, and then we actually want the chloroform layer, which is the layer that's on the bottom. So we drop off our chloroform layer, we can actually drain it. And we want to get as much of the chloroform as we can, but ideally what we really just don't want is any of the aqueous layer. Should be able to see the separation between the two phases. You can see where the phases are separated right here. All right, so now that we've got our chloroform layer, get a little bit more of this one.